What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding derivatives of trigonometric functions. First example is y equals to sine x plus cosine x times secant x. You know the derivative of sine x is cosine x. Derivative of cosine x is negative sine x. And derivative of secant x is secant x times tan x. So whenever we are dealing with such examples, we can say we can use product rule. Derivative of uv is going to be u prime v plus uv prime. It means that the derivative of the first one times the second one plus first one times derivative of the second. The derivative of sine x plus cosine x is going to be cosine x minus sine x times secant x plus sine x plus cosine x times derivative of sine x, which is derivative of secant x, which is secant x times tan x. Now let's simplify it. We have cosine x minus sine x times 1 over cosine x plus sine x plus cosine x times 1 over cosine x times sine x over. So that's going to be cosine x over cosine x minus sine x over cosine x plus sine times sine, the sine squared over cosine squared, cosine cos, plus cosine x times sine x divided by cosine squared x. So when you simplify it, this one is going to be 1 minus sine x over cosine x is tan x. Sine squared x over cosine squared x is going to be tan squared x. Cosine and squared cancel out. It's going to be sine over cosine, which will be tan x. Now tan x and negative tan x is going to cancel each other. So we're going to end up having 1 plus tan squared x. We can solve this example in another form. Sine x plus cosine x times secant x. If we use trigonometric identities, we can say that's going to be, secant is 1 over cosine, it's going to be sine x over cosine x plus cosine x over cosine x. So this is going to be tan x plus 1. Now the derivative of tan x is 1 plus tan squared x. Derivative of 1 is 0. So again, we got the same answer. This one was much easier. Let's see the next one. It says cotan x over 1 plus cotan x. Now let's use trigonometric identities and see if we can make it simpler. Cotan is cosine x over sine x over 1 plus cosine x over sine x. Then in the denominator, we can have the common denominator. Instead of 1, I can write sine over sine because the denominator here is sine. So it's going to be sine x plus cosine x over sine x. Then these two cancels out and we're going to end up having cosine x over sine x plus cosine x. Now let's find a derivative. U over v is going to be u prime v minus u v prime divided by v squared. In this case, u is cosine x, v is sine x plus cosine x. U prime is negative sine x, v prime is cosine x minus sine x. So u prime is negative sine x times v, which is sine x plus cosine x minus u, which is cosine x times v prime, which is cosine x minus sine x, divided by v squared, which is sine x plus cosine x squared. Now let's simplify the numerator. This negative sine times sine, it's going to be negative sine squared. Negative sine times cosine, negative sine x cosine x. Here negative cosine squared x plus cosine x sine x over sine x plus cosine x to the power of 2. Now this one and this one cancels out. And we have negative sine squared x minus cosine squared x. If I factor negative, it's going to be sine squared x plus cosine squared x divided by sine x plus cosine x to the power. That's going to be negative 1 over sine x plus cosine x to the power of 2. That's the answer to the derivative of this function. Next is y equals to cosine x over 1 plus sine x. Again, we're going to use u over v. It's going to be u prime v minus v prime u divided by v squared. U prime is the derivative of cosine, which is negative sine x. V prime is going to be derivative of 1 is 0, derivative of sine is cosine x. So it is going to be negative sine x times v, which is 1 plus sine x, minus v prime, which is cosine x times v, which is cosine, divided by v squared, which is 1 plus sine x squared. Now let's simplify the numerator. Negative sine times 1, negative sine x. Negative sine times sine is negative sine squared x. And then here we have negative cosine squared x. Then I factor negative 1 from here. It's going to be negative sine x minus sine squared x plus cosine squared x. You know, sine squared plus cosine squared is always 1. So we have negative 1 plus sine x in the numerator, and in the denominator we have 1 plus sine x to the power of 2. Then cancel out, it's going to be negative 1 over 1 plus sine x, which is going to be the final answer. Now, next example, y equals to 4 over cosine x plus 1 over tan x. We can do it in different ways. 1 over cosine is equivalent to secant, so it's going to be 4 times secant x plus 1 over tan x is cotangent x. We had it before, the derivative of secant x is going to be secant x times tan x, and the derivative of cotangent x is going to be negative 1 plus tan cotangent squared x. So we can sub it there. Y prime will be 4 times secant x tan x plus, actually it's going to be negative because plus times negative is going to be negative, minus 1 plus cotangent squared x. So that's going to be the derivative of this function. Next one is y equals to cosine x over x plus x over cosine x. So what we can do, let's have a common factor. It's going to be cosine squared x plus x squared. That doesn't really do much for us. So let's keep it simpler, because that's going to get more complicated if you do the common denominator. So let's stick to the first original function and find out the derivative. So u over v, u prime v minus v prime u divided by v squared. So it's going to be negative sine x times x minus cosine x times 1 divided by x squared. Here, derivative of x is 1 times cosine x minus x times derivative of cosine, which is negative sign, over cosine squared x. Then it's going to be negative x sine x minus cosine x times cosine squared x plus cosine x plus x sine x times x squared over x squared cosine squared x. Then you can simplify it. It's going to be negative x cosine squared x sine x minus cosine cube x plus cosine squared x times x squared plus x cubed sine x over x squared sine squared x. That's the derivative of cosine x over x plus x over cosine x. Hope you enjoyed this video. Please leave me a comment if you have any question and I'll get back to you as soon as possible. Thank you for watching and have a great day.